Hi everyone, my name is Amitesh, and in this video we're going to talk about a super cool example of a function. It's a product of two functions, each of which is not differentiable at 0, but the product is differentiable at 0. And we're going to prove that with the limit definition of a derivative in 5 minutes. And this is, as I've taught at Princeton University, this kind of function has appeared, and I'm going to present it to you in the same way, and I'm going to show you exactly how to think about the limit definition of a derivative. It's also going to be practice with limits, and it's going to be super cool. So first of all, why is this function a product of two functions that are not differentiable at 0? So cube root of x squared is not differentiable at 0. Why is that? Because the cube root of x squared is equal to x power 2/3, right? And let's say you try to use the power rule to differentiate it. How would that work? Well, you would then say the derivative of x power 2/3 prime, and I'm writing this in red because it's wrong. This is going to equal to 2/3 times x power 2/3 minus 1, which is going to be 2/3 times x power minus 1/3. Okay, now this is actually perfectly fine as long as x is non-zero, but if x is 0, this doesn't work. Okay, and to actually prove it's not differentiable at 0, you have to use a limit definition of the derivative. So I encourage you to try that out. Drop a comment down below, what is your argument? How do you think about it? Did you do the argument? Even if you did it, just drop a comment down below, say you did it. That helps with engagement on my videos, which I love. And any other thoughts you have. But this is why, very intuitively it's not differentiable at 0. But when we take the product of these two functions, we're going to get something differentiable at 0. And you can't prove this with the product rule, right? Because the product rule only applies if each of the functions is differentiable. It tells you what the derivative of the product is. If neither of the functions are differentiable, but somehow the product is, well, you have to do it another way. So how are we going to do it? We're going to use a limit definition of the derivative. So let's work that out, okay? So limit definition of a derivative is going to be the following. So we're going to say limit h goes to 0 of, basically it's going to be f of h minus f of 0 by h minus 0, right? That is the slope of the secant line passing through 0 and h corresponding to the points on the graph. And as h goes to 0, that approaches the slope of the tangent line, which is the derivative f prime of 0. So here, of course, f of x is the function up top. So let's just plug that in. So what we're going to do is we're going to get the following. So it's going to be limit h goes to 0. And here we're just going to define, you can directly say that at x is 0, this is going to be 0. Okay, you can take this function. It is defined at 0, which it has to be if it has to be differentiable at 0. So here you're going to get cube root of h squared times sine of cube root of h divided by h. Okay, that's going to be our answer. Now here's what's the cool thing. Okay, here's what's the cool thing is we've got this limit here. It's a 0 over 0 indeterminate form. Okay, now that's always the case generally. When you're trying to differentiate a continuous function, your f of h minus f of 0 is going to approach 0 as h approaches 0, and your bottom is also going to be 0. So in that case, you want to sort of think, either I cancel something from the top and bottom, which is contributing to the 0 over 0, or I use some trigonometric trick, which is the case here. And we're going to use a fundamental limit, and I'll have a video on that in my channel, but first I will show you how it reduces to that. So here we can just cancel off. We use exponent laws. So h you can think of as cube root of h squared. Okay, you can think of h as cube root of h cubed. Okay, so cube root of h cubed. So another way of looking at this is you've got the top is h power 2/3, and the bottom is h. And what you can do is h power 2/3 over h is by exponent laws, you're going to get a h power 1/3 down bottom. So here I'm just going to erase that here. You're going to get limit h goes to 0 of sine of cube root of h, which is just h power 1/3, divided by cube root of h. Okay, so the reason for that is, as I've said, if you're dividing h power 2/3 by h power 1, it's going to be h power 2/3 minus 1, which is going to be h power negative 1/3, which is going to be 1 over h power 1/3, which is just 1 over cube root h. Okay, so that's why the cube root h comes down bottom. And now we've got something of the form sine of something over something. Okay, and that something is going to 0. This is a famous limit. It's a fundamental limit in trigonometric 0 over 0 limits. You can reduce any limit to solving this one. Okay, and I've done a video on that on my channel. If it's uploaded at the point of you're watching this, it'll be in the link down in the description below, or you can check out my channel and find it. It's called the magic spell for trigonometric limits. And what I'm going to do is I'm going to now show you, so this is the limit that we're using. Limit h goes to 0, so it's limit, u goes to 0 of sine u over u is equal to 1. Okay, this is a fundamental trigonometric limit that basically says sine u approaches, it's basically like u as u approaches 0. And here if we set u is cube root of h, then the thing we have to verify is that if u is equal to the cube root of h, then u goes to 0 as h goes to 0. Okay, so we really have it of the form sine of something by something where the something is going to 0. And then we can therefore say that this limit is also going to equal to 1, and that is the argument. Okay, so that means the function is differentiable at 0 and its derivative is 1, which is super cool. It's a limit definition of the derivative that proves that. So thank you so much for watching. I hope you loved that video. And I'm just going to keep this short, but I'm trying to create infinite, elite, free, accessible math education worldwide so everyone can love and benefit from math. Okay, not just people in high schools or colleges who have access to certain resources, but everyone. I love explaining math. I love teaching and sharing math. I'm doing my best to create a library of math content that maybe can't be found anywhere at all levels of math. You know, not just one level or the other, but all levels, so that as you kind of watch my channel, you can get exposed to lots of topics at all kinds of levels. And if you subscribe, you're constantly going to be exposed to different kinds of math. You can share with your friends and family, even if they're at a lower level or a higher level than you, they can still benefit from my channel. So that's my goal, and it's like a cheat code, you know, just to subscribe, get exposed to all this stuff, and it really helps me achieve my vision of changing lives through math education. Thank you so much for watching. I'm so grateful you've watched this video, and I'm super excited to see you in the next video. Please take care, wish you all the best, and I'll see you soon.